Hey, we are going to finish up our linear and exponential functions with kind of generalizing or making conclusions about how our table, graph, function, and recursive rule should be written. So whenever we talk about linear functions, it's a linear function if the differences are constant. So what I mean is wherever you go from this one to that one, it's the same difference as this one to this one. I'm going to put it like that. Okay, so whenever we talk about the 0 as x, the y is going to be a. This is our starting amount. Whenever you have 0, it's called our start. It's also called our y-intercept. Whenever a is 0. And this is called a sub 0, kind of like our bell ringer today. And then the first one is a sub 1, or whenever x is 1, a sub 2, a sub 3, and a sub 4. Sub means subscript. To get our y value, we have a plus some value d. D represents the common difference. So difference is, what is the difference between A0 and A1? So we know to get from A0 to A1, we just add a D, which gets us A plus C. And then the next one, we add a D again. So that means it's A plus D plus D. It's an easier way to write that, though. Well, what is this repeated addition? Yeah, it's repeated addition, which is multiplication. So this should really be written as A plus 2D. And then, so the next one, we are adding D again, so that's A plus 3D. And then the next one would be A plus 4D.
Why? Oh.
Because you've added D to this 4 times. Plus D, plus D, plus D, and plus D. So it's been added 4 times. So we have the table. Then to go to the graph, all you need is a couple of points. So our first point is whenever x is 0, y is a. So I'm just going to say that this value right here is a. And we know that linear functions make a straight line. So let's just make a straight line with it. Okay, let's look at our sequence. Whenever we write our sequence, we write our first term, second term, third term, fourth term, fifth term. So we are going to start with A1. A0 is the zero term. We're not going to write that in our sequence. So this should be written as A1, A2, A3, A4, and A5. We do not include 0 in the sequence. Because if I want to find the start value or the y-intercept, I always have to go to the one right before it by subtracting. Then our recursive rule, our start amount is what A0 is. So we're going to write A sub 0 equals A. And then it's A sub n equals A sub n minus 1. It's like saying next equals now plus D for that difference. Like our bell ringer that we did today. And then our function, it's a linear function. So linear functions are written as mx plus b.
Fx is the same thing as y equals.
Yep. Where m is your common difference. And b is your y-intercept or our start. Okay, so that's linear. We've been learning linear for 3 or 4 months, 5 months, 6 months. I don't know. Most of the year.
Years, eh?
Most of the year we've been learning about linear. So now let's look at exponential and how they're the same, but then how they're different. Exponential functions, if the ratio is constant. So ratio is like a division problem. So it's like saying this is A0, this is A1, A2, A3, and A4. The way you find that ratio is by dividing whatever you have now divided by your previous. So an example would be like A sub 1 divided by A sub 0. What I have now divided by the previous. Or I could do A sub 2 divided by A sub 1. Or I could do A sub 3 divided by A sub 2. So you're dividing between them. You want to do now divided by previous. So that's how you can find your ratio, which is also your rate, your constant rate. So A sub 0 is A. It's your start. So you can write that here too. Start or y-intercept. I'm going to abbreviate intercept. Mm-hmm. Yep. A times our ratio. So let's use R. So let's say that the ratio is R. So this will be A times the ratio or the rate. So here we are multiplying by R for exponential. So to go from one to another, you're multiplying by R. Sit up. So then the next one, A times R again. That's repeated multiplication, which we can replace that and make it easier and say that R times R is R to the second power. So then the next one would be A times R to the third power. So then the last one would be A times R to the fourth power.
A.
So then our graph, if it's exponential, if it's, yeah. So let's say that this is A. That is an A. So then we are going to kind of skate along the bottom and then go up. Okay, and then our sequence is starting with A1, which is our first term, second term, third term, fourth term, and fifth term. You start with your first term.
Yeah.
And then the recursive rule is found by doing, or like this. But what's different about linear and exponential?
This one's just going at a faster rate than linear.
It's going faster. It shoots up faster. And also it's being multiplied. Instead of plus D, I'm going to do times rate.
Linear is addition and subtraction, and then exponential is like multiplication and division.
So A sub 0 equals A. That's your start. And then A sub n equals A sub n minus 1 times the rate. Whatever the rate is. So these are the same. The only thing I changed is linear is plus D, exponential is times the rate. And then the last thing is our function. We write this as A times B to the X, where A is your start or your y-intercept, and B is that rate or that ratio. Okay, last thing we're going to write them here is what kind of sequence they are. So we learned about sequences a little bit. Do y'all remember what kind of function or linear functions have what kind of sequences? Do y'all remember? Going to start spelling it. Arithmetic sequence. So linear functions are arithmetic sequences. But what about exponential?
Multiplicative?
Mm-mm. Geometric, yeah.
Oh.
Yeah, you were close. Geometric sequence. I don't know why there's such a space there. Mess up. All right, you're going to fold this in half and glue it in your journal. This is what your title will look like. Shout out to fourth period. Make sure y'all study for your test.
Hey, everybody.